So all the way back before finals, and I think after break, but before finals in January, we started talking about our natural selection notes, and I know it was in our other Google Classroom. So I'm just giving you these that are already filled in, and we're just going to kind of go through it as a reminder of what we wrote down. So in box A, it says, what do these three stories have in common? So I had told you the story of the bacteria, the finches, and the peppered moths, and how they changed over time. So you guys told me three things at least that they had in common, which were that there was a change of some kind. They were all living things, so they were all living organisms, and they all tried to stay alive or avoided dying out. So something happened where they wanted to keep staying alive. And we identified this phenomenon, or that puzzling fact, that something, we figured out, something in those living things, their traits or their characteristics, were changing over time. Then I asked you guys to just fill out box C, where it says questions you have about this phenomenon. And a few people said a few different things. The ones that I could remember were like, do the characteristics ever change back? So did the finch beaks ever go back to a smaller size? Or why doesn't the organism just die out? Like, why do they change in order to stay alive? Like, why don't they just go extinct? I know there were some other questions, like maybe did the bacteria ever become resistant to a new medication? Things like that. Again, I'm sorry if we lost the notes or if you just don't know where they are. But if you had any other questions about those that you can remember, you can add them in box C. After I gave you guys all of those stories, there was a question that we were trying to solve, is how do these traits change over time? This is our puzzling fact, the thing that we want to figure out what is going on. And when I asked you guys this, you guys came up with a few ideas. You guys said things like mutations, adaptation, climate change, or they were struggling to survive. They wanted to stay alive, kind of like how you said they avoided dying out. So these were the initial models. We knew something about the animal or the organism was changing. It might have had to do something with climate change because we talked about that with populations. And then a few classes brought up the word mutation, and now we're going to try and figure out what these words mean. So what we went into was the finch graph specifically. And what our specific question is, why did the average finch beak size change over time is what we have been investigating, and why we've been looking at these finches every day for like 3 weeks. So we're going to review just what we've learned and done so far. In that, we're trying to figure out how traits change over time. And to figure that out, we looked at the finches and determined what may have caused the average beak depth and population to change over time. We analyzed a data set of those graphs, and then we put our data into a timeline, and then we helped us uncover evidence that answered the question in our CER. We already developed our story based on our CER. So now we have our model, and we're going to further explore our ideas and see if we can find additional evidence that supports or refutes or goes against our claims. So we'll start with our ideas related to the change in population size of the finches. So where else have we observed changes in population sizes? What did we do in the past unit? What kind of animals did we look at with population sizes? If you thought about the moose and the wolves right away, or wolves right away, that would be the perfect example. We looked at how mates and weather and food and predators and prey all kind of were connected in how populations rise and fall in population dynamics. So then when we looked at our finches, so first we started with our moose and wolves and all that, and then we did our finches. So in the information from the CER, things that we should have noticed or what we talked about in class together was that the smaller beak finches died and they didn't get enough food, the small beak finches, some of them died, but if they did survive, they just couldn't get enough food to sustain their own nutrition and a baby's nutrition. So if they did survive, they were just not getting enough nutrients and they couldn't have their babies, which caused the bigger beaked finches to survive, and they could have their babies because they could open up those harder, tougher seeds. The babies that were born then in the years 1977 and 1978, the ones that lived of the babies also had bigger beaks to open up those harder, tougher seeds. I just said that the seeds got bigger and tougher because of a drought. So that is all very specific information to the finches. And what we need to do is now apply that to other animals and organisms like the moose and the wolf and the squirrels and humans and all these other things, the moths and plants and fish, and we're going to see how these little tidbits of information from the finches, why does that matter? How can it relate to all these other organisms that live in the world? So here we have a revised model idea for box H. And so what we're going to do is we take each idea from the finch-based model, and now we're making it more relevant and more like widespread. So that drought would be a change in the environment and weather. So there's not always a drought. Maybe there's extra rainfall. Maybe it's just super hot. Maybe it's humid. Maybe it's too cold. And then the seed changing would be a change in their resources, their food sources, their water. The fact that only the large beaks survived because they could open up those harder, tougher seeds is the fact that a better trait survived. It's not necessarily the strongest trait. Just because you're big and strong doesn't mean you're best suited for that environment. So it's whatever better trait survived. The fact that some of the finches died and some lived is our population changes, so those birth and death rates that we talked about. And then the last one about the babies and having nutrients to survive and passing that on would be that those that survive pass on that better trait to their babies. So if they are surviving, they're passing on the more beneficial trait for that time period or that environment. So that's all in box H. Then now we're gonna consider this question, and you're gonna make a prediction. So what you're gonna do is in box, I forget what, but we're gonna consider the following question. What if there was no starvation in the finches? What if all the finches could open up any size seed and they could all eat and live off of those nutrients? What if all the parents and all the offspring had survived? What would happen to this population? So in box I, we're gonna doodle sketch our thoughts. So if you're in our notes, you're gonna go to box I right here, and you're gonna hit this edit button. And if you have a mouse or a touch screen, this is the best way to do it. You select it and you go to this like bar, scroll down to the scribble button. And you're gonna scribble with either your mouse or your finger if you have a touch screen. What your prediction is if there was no death and all the animals lived. So do you think it's gonna look like this? Do you think it's gonna start really low and then go up and then level off and go down? Do you think it's just gonna go up and down? Write your prediction of what you think is gonna happen if there's no starvation. Then you can save and close it. I'll have to go back in, hopefully get rid of it, but then they all show up right there. And now we're gonna actually see what happens. So here's a simulator. We have like two little, I think maybe three finches. There's 3 finches here. And we're gonna see what happens if they can all survive, and so nobody dies, there's no starvation. We're gonna see what happens to the population. So if you look down in this corner over here, right here, it shows that it's going up, 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 total, 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 total. And if you did your AWA, we know what this is called. Oh, we'll keep it going. So you can see all the finches populating, and it's starting to get all these black finches on our graph. So if you did the AWA, you should know that it is exponential growth. So there is no starvation and no death, and it looks like that. And now we're gonna see what happens if there is starvation, or like the real world, because we know that this situation is not sustainable. So we're gonna push the switch button, and you all need to make a prediction first. So we found out what happened. And now you're going to predict what would happen in the real world. So obviously they don't do exponential growth all the time. So we're gonna see what happens if we put on limiting factors. So there is our graph, and if you did the AWA, that is called logistic growth. So here we have exponential growth, no starvation, and then in box L, you should draw your graph looking somewhat like that, with logistic growth and having it level off over time, and that is a real world example.